Let's go over the first idea of testing, and that's going to be this idea of incremental testing. So, incremental testing is testing where you create a module, you do some tests, you create another module, you do some more tests. And this word create is used loosely. So, we can do testing in two different ways, and we'll talk about this a little bit more when we get to software models. And that is, we can either build a module and then test, build and then test, or maybe we can build the whole system and then with this testing, we grab a module, then test, grab a module, and then test. So when I say create, I either mean we're building it from scratch or we're grabbing it out of the program we've already developed and we're testing them a little bit at a time. So with the incremental model, what we have is we have these steps. So for example, we might grab a module, maybe the top level module, the starting module. And then what we do is we test it. See if it works how we want it to work, see if it's doing what it needs to be doing. If it does, then we move to the next step. Maybe it connects in these two areas. So then we add in another module, and then do some more tests. Make sure all of these are working together properly. Add in another module. Maybe there's one right here that communicates like this. So then we'll test these and we can just do little check marks to say where we've been. So we can say here, here, and here. So then we do two more tests. Now we've checked here and here, and so on until we have basically tested the entire program. And you can see that this is actually a pretty decent way of doing it just because we are testing it in this way in which we're slowly adding more and more in and testing functionalities. The problem with this is it's very hard to accomplish properly because maybe your software wasn't built so that it is completely and totally modular. Maybe there's a little bit too much coupling in it. Maybe there's not enough cohesion. And therefore, whenever you increment a step, maybe it's like you start off with 10% and then you increment one step and then suddenly you're up to 40% of the code and one more step and now you're up to like 95% of the code. And that happens a lot. Which is why this sometimes isn't as practical, but it is very important, this idea. Another shortfall of this is, for example, if we just wanted to test the relationship between these two units, well, by the time we get to this over here, what we have is we're sort of testing the entire system plus this. So in this situation, we might even have to add another step where we do the incremental testing and then we do like a little bit of a unit test here where we test just a specific area. To see if each one of these works, and then if this works, and then if these work. So there's like a ton of different ways to do this, and that's why it makes it just a little bit difficult. Now, a couple of different ideas for doing a sort of incremental testing is this idea of top-down testing. So with top-down testing, what we have is we have this idea of basically we're testing the top level and then we move down after each top level is completed. And we're going to need to learn a new terminology here, and that's this idea of a stub. And a stub is a template of the model that will be implemented, typically returns hard-coded values. So what do we mean by this? Is let's say we're testing this module up here, and we'll say that this is, for example, level 1. So we're testing the very top module. Now, the thing is, we're not testing anything beneath it. We're just trying to test this module. Therefore, what we create is these ideas of stubs down here. So this next layer is going to be a stub. Everything in red will be a stub here. And what a stub does is it's just a template of the model that will be implemented. So instead of having all these methods that are fully, realized, we might have the ability to call the function. So this is where you need planning as well, because you're going to have to know exactly what method calls, what functions, what subsystems are basically entangled in each of these little subcomponents. So for example, over here, maybe this is a clock or something. So we might have a get hour. Maybe we'll have a get minute. Maybe we'll have even maybe like what's tomorrow, get tomorrow. Just add a little get there, get tomorrow. Maybe we have all these functions, but we haven't actually implemented them yet. But we want to see if they'll work in relation to this. So what we do is we create this stub where we don't actually fill in any of the code beneath it. We create all the method calls, but we don't implement any of the method calls. All we do is we return some hard-coded values or something that, makes it so that we know it actually called that function. And, something like that. It might just be like a console. .log if you're working in something like JavaScript, where we can say tomorrow it'll just return a random date in there. And so that way we know if it returns this exact date, we've accessed it and we've gotten the information properly. And this helps because maybe it calls down here and then it calls back up and we do something with the data. So we need to make sure that this control flow is working. We need to make sure that if we call our method up here, it goes down, it grabs the proper method, and then it comes back up and everything is sort of flowing along nicely. And that's why you need these stubs. And again, this can either be a way of developing or a way of testing. So maybe with our development, we're doing sort of a top-down development as well. So we build level 1 and then the stubs that connect to it. And then after this is complete, then we actually build out each one of these stubs. We implement them, and then we create a new layer of stubs that we have to use. So, more stubs down here. And this is also helpful if, for example, we have a database that we're going to use, but the database isn't implemented yet. So we can actually create this stub that instead of calling the database, instead of calling it, it just, again, returns that console.log. So maybe we say something like get user. So we try a get user command. And typically that would be the user would be stored in the database. But in this situation, all we do is we just return user information, fake user information, and we can test it without actually developing our database right now. And then, of course, when we get to the point of developing the database, then we'll actually implement this and we'll keep moving from there. You can see there's a little bit of a nice organization here. There's a flow. We have these objectives we can accomplish. We start at level 1, then we move to level 2, then we move to level 3, and we keep going and so on and so on. Level right there. And that is basically the way that we do top-down testing. So we start at the top and we keep moving down. The other way that we can do is this idea of bottom-up testing, which is just basically the reverse here. And what we need for this we need drivers. So remember back here, we already had this module right here, which is calling commands. It has the variables initialized. It has everything that we need for these to operate down here because it's top-down. The control flow is going top to bottom. So it's passing in certain variables. It's passing in certain information. This then executes and then it comes back up. And this is controlling that execution flow. Well, with bottom-up testing, how do we test, for example, let's say we have these bottom 3 down here. How do we test these if we wanted to start at the bottom? And maybe we want to start at the bottom because, for example, maybe the top is like the server and maybe the bottom is like the front end. And we want to make sure the front end works before we actually get to the servers. So in this situation, we need to start at the bottom and we need to work our way up. And so what we do is we test these modules and we actually have these things up here called drivers. So we create a driver, which is essentially the same thing as a stub, except just the opposite side of the coin here. Instead of it being a template that has model controls, a template that has, functions that might return, it's a template that has execution controls. So up here, we might have functions that aren't fully implemented, but that call the right other functions down here. So we might have, a get time up here. And what this is going to do is it is going to make the appropriate calls. Maybe this again is that same clock one here. So the get time is going to make a call to, for example, let's say it's going to make a call to get hour and then get minute. And then maybe a couple of other things. And then it's supposed to combine them and maybe return it even farther up. But in this situation, we now have this driver and we can test whether the commands coming in are returning appropriately. And so what we do is we create this little driver. We make sure that all of the variables up here are initialized. Maybe it needs to pass in the time zone. Maybe the time zone is something it needs to pass in. So we go ahead and we create a variable called time zone. And we initialize it to just something. So let's go with Eastern Standard Time, which is usually abbreviated as ET. This is United States Eastern Standard Time. So we set the time zone. Of course, if this was a real program, this would be maybe calling to a database to see what the user is or something. But in this situation, we're just creating a driver. So we hard code all the variables. We hard code some of the methods in here. And then now we can test to see if when calls come in, do the appropriate data get returned here. And then in this one where we hard coded the console.log, tomorrow is a time, maybe we say it's like February 19th of 2012 or something, where we actually hard coded in, This one, because we're testing the module, the bottom end, it's going to return the actual get hour and the actual get minute and the actual get tomorrow. It'll do those things. So all we need to do is we need to have something to call it to check to make sure that those things are working. And then of course, once we finish that out, we go ahead and we actually initialize this and we keep moving up the chain until we've tested everything. And so that is really incremental testing in a nutshell. It's this idea of starting somewhere. Doesn't matter if it's bottom, top, there's different other ways to increment, and then just move to the next one once we're done, move to the next one once we're done, keep checking them off, and then keep incrementing until you have tested every module in the program.